Welcome back, friends. This is Dr. Mlelwa Lecturers. Don't forget to click the subscribe button and to click the bell. Then put all for more updates. To join our Telegram group for discussions, just click show more in the description. Then if you scroll down, you see the links for the O-level and the A-level group. Welcome back, friends. This is Dr. Mlelwa Lecturers. On the facilitator in this session, I am Dr. Mlelwa. We are continuing with the advanced chemistry sessions, and this is states of matter. In this session, we are going to start about the solutions as a liquid state. As I told you that in the previous session marks the end of gaseous state. So in this session, we are going to start with the liquid state. So first thing that we will be dealing with, or we're dealing with more in this session, is solutions. Kwa hiyo kwenye hii topic au kwenye hii subtopic tutadili na solutions. So first, we should understand the definition of mixture. I know this is just the Form 1 terminology. Mixture is the combination of two or more pure substances. Pure substances. Combination of two or more pure substances. And a pure substance is the substance that has homogeneous and invariable chemical composition. Invariable chemical composition manake tukisema pure water manake composition yake ni hydrogen and oxygen. And the composition of pure water anywhere duniani inakuwa ni ile oxygen and hydrogen. But impure water means ile water imekuwa contain impurities. Impurities ni kama uchafu. So impurities, they can be mineral salts. Impurities, they can be dust. Impurities, they can be organisms, microorganisms such as bacteria. Kwa hiyo, a pure substance is the one that has homogeneous and invariable chemical composition. So it may exist in more than one phase, but chemical composition is the same in all phases. For example, when you are talking of water, water can exist as vapor, as a liquid, or as ice. But the composition of water remain oxygen and hydrogen. So components of mixture may be differed in the same phase. Therefore, mixture are classified into. So the components of mixture may be different or may be the same in phases. If you don't understand the meaning of the term phase, phase means state. When we are talking about phase, means state. In this topic, we are studying about states of matter. So phases, we have three phases: solid phase, liquid phase, and then we have gaseous or vapor phase, vapor or gaseous phase. So we have two types of mixture generally: heterogeneous mixture and homogeneous mixture. Heterogeneous mixture, the mixture whose components are in different phase. Example, a mixture of sand, which is solid phase, and water, which is liquid phase. That is the heterogeneous mixture. And we have homogeneous mixture, the mixture whose components are in the same phase. Example, mixture of water, which is liquid, and ethanol, which is also liquid. So mixture of water, which is liquid, and ethanol, which is liquid, are the two mixtures, the two pure substances, which are water and liquids. Water and ethanol, they are both liquids, so their mixture is termed as homogeneous mixture. So we have the classification of liquid homogeneous mixture, because as I told you that in this subtopic we will be discussing about the solutions. So we are discussing more about liquid homogeneous mixture. Now liquid homogeneous mixture, they can be classified into three major groups. The first group is miscible liquids, then you have partially miscible liquids, then you have immiscible liquids. Miscible mixtures or miscible liquids or miscible liquid mixtures is the homogeneous mixture whereby component constituents tend to mix completely so that there is no formation of layer of components. So for example, if you mix ethanol and water, most often utaona mix moja kwa moja and no formation of layers. So you not recognize where the ethanol, where the water. Now, kwenye hii topic
Hatuzungumzi tu kumix completely, no. But we are dealing with the fact behind why are they mixing completely. Now, when we are studying the states of matter, we don't only need to understand that they are mixing completely, but we need to know about the fact behind the mixing completely. Now, the fact behind the mixing completely is the intermolecular force of attraction between the molecules. So, let's say we have a mixture A, and this mixture A has molecule A, and then has another molecule A. So here we have the intermolecular force of attraction between A molecules, let I call by small a. And then we have mixture B. This mixture B has one molecule B and another molecule B there. Then we have the intermolecular force of attraction between the molecules of B, let I call it small b. Now, if the intermolecular forces A and B, they are equal, that means the attraction between A and A is equal to the attraction between B and B. So that attraction also will exist between I and B. Attraction which is equal to A and is equal to B. So that means what will happen in solution, it is A, then bonded to A, and this can bond to B, this can bond to B, or can bond to A. So that is how the miscible liquids, they are made up. The intermolecular, a certain intermolecular force A, and here a certain intermolecular force B, here an equal intermolecular force exists, and the magnitude of this and this force, they are equal. Kwa hiyo mixing completely is because the intermolecular force of attraction, they are equal or they are approximately equal. Kwa ninachokisema ni kwamba this occur where the intermolecular force of attraction in pure liquids are equal to the intermolecular force of attraction in the solution. Intermolecular force of attraction in pure liquids are equal to the intermolecular force of attraction in the solution. So intermolecular force of attraction in A and in B, they are equal. Also, they result into an equal intermolecular force of attraction C in the solution. So this is the intermolecular force of attraction in the pure liquid A, and this is the intermolecular force of attraction in the pure liquid B. But this is the intermolecular force of attraction in the solution. This makes the completely miscible liquid, the illustration has explained below here. So now let's go on the examples of miscible liquids. We have the mixture of benzene and methyl benzene, that is toluene, and we have the mixture of propan 1-ol and propan 2-ol. They have the same molecular mass, but the difference is just the position of hydroxyl group. We have the mixture of hexane and heptanes, and we have the mixture of water and methanol. So these are just the examples of completely miscible liquid mixture. And then let's move to the partially miscible liquid mixture. Partially miscible liquid mixture. So the homogeneous mixture whereby its components tend to mix slightly. And again, the fact behind is intermolecular forces. So if they are mixing slightly, means there is a slightly difference in the intermolecular forces. This occurs when the intermolecular force of attraction of pure liquids do not differ much with the intermolecular force of attraction in the solution. There is difference in the intermolecular force of attraction, but do not differ much. That means if you have two pure liquids, let's say the liquid I, and then you have the liquid A holded by the intermolecular force of attraction, let I note it as A, and then you have another pure liquid B holded by the intermolecular force of attraction, let I call it B. Now the intermolecular force of attraction between A and B here will be either A plus B. So let's say the intermolecular force of attraction in the solution, call it C. Now will be either A plus B, I mean A, which is equal to B, can be, maybe this value can be either is greater to C, or A which is equal to B can be less than C. So actually the fact behind that, even A and B, they are not actually exactly equal. And this normally occurs if these two molecules or two pure liquids mixed, they are very quite different molecular masses. because as we know that the molar mass of a compound is also defined or is also determined by its molecular weight, as we studied in general chemistry. So the same concept is applied here. For example, when we studied about the complete soluble mixture, we said that we have the liquids such as benzene and toluene. If we study about the molecular masses, the molecular mass of benzene and toluene, they just differ a very small quantity. But here actually, intermolecular force A is not equal to intermolecular force B. And this cannot be equal to a new intermolecular force which will be formed in the solution. So actually that's what happens, that we have the molecule A and then we have the intermolecular force A here. But here, the intermolecular force, because they are not equal, so another molecule B here with force B. So intermolecular force of attraction A is not equal to B, and that is that to interaction between these two molecules to be very difficult. So the examples, we have water and the propanol mixture, water and the phenol, and the water with the ethyl ether. So let's move to the last category of liquid mixture, which is immiscible mixtures. Now this is the heterogeneous mixture whereby its components do not mix at all. So they do not mix at all, and at the end of the day they form layers, so that they tend to form spring layers between the liquids. They form layers. For example, if we have water and the kerosene, or water and vegetable cooking oil, they form layers. So they do not mix completely. And that is because the intermolecular force of attraction in the pure liquids is not equal, or is quite different. So example is kerosene and water. This occurs when intermolecular force of attraction in pure liquids differ with intermolecular force of attraction in the solution. So upper intermolecular force of attraction, they are different. So it is strictly saying that if we have the molecule of A and A, it is not equal to the B and B. It is not equal to. So that's all about the. So here, kerosene and water is just the example. We have many examples of immiscible liquids. So for example, with the aid of examples, define immiscible, partially miscible, and immiscible mixtures. But I hope for the case of our discussion about the introduction to the mixtures and the types of mixtures and examples, I hope we are together. So I'm ending up here. In the next session, I will start discussing about the solutions and the ways of representing the concentration of solutions. So in this lecture, let I end up here. Don't forget to comment the video if you don't understand anything. Join my Telegram group for more discussions. Subscribe to the channel, and don't forget to even contact me for the need of notes. Thank you, everybody. That I wish you nice studies.